All right, guys, we can see the answers for your homework last night. It was your forces worksheet. You had up to number 13 for homework last night. The answers from 1 to 13 are up on the board. Take a look at those. See if there's any issues that you had with any of those questions, and then we can take a look at which ones you need to go over here. Number 4. Any others besides number 4? Right? 6, 4, 6. Bo? 2. 8, 9. Okay, we got quite a few here, obviously, and that's okay. No, keep going. 11. But if we do find that there's a couple that are pretty much the same, then what we'll do is pick one of those two questions if they're the same. If they're not, then we'll go over them all. Yeah. Okay. 7. All right. There's a big group of them. 6, 7, 8, 9, 10, 11. All right. I think that's pretty representative of the group of questions. In fact, I'm pretty sure that we're going to be able to skip a couple of these questions just because if we can do, for instance, say if we can do number 11, then we're probably going to be able to do number 10 as well. All right, number 2. Number 2, first of all, is an elevator question here where we have the force of the floor pushing up on the person in the elevator. So it looks something like this. You got the person like this. You get the mass of the person is 50 kilograms. And you've got the acceleration of the person is 2.00 meters per second squared. And it's downward. So we're going to make that a negative acceleration. We got two forces acting on this person. We've got the force of gravity. And we've got the normal force. Hey, is the normal force going to be bigger or smaller than gravity here? We should know this by looking at the acceleration, whether the normal force will be bigger or smaller than gravity. It's accelerating downward. Which force is bigger, the upward force or the downward force? The downward force. That means that Fg is going to be bigger than Fn. So let's draw that shorter. How much shorter? Don't really know, but we're not going to worry too much about that. All right, let's say the net force is equal to the sum of the forces. That's what we do next, always. Let's say m times a is equal to the sum of the forces. That's what we do always. The mass here is 50 kilograms, and the acceleration is negative 2.00 meters per second squared. Fn plus Fg. The value of Fg is going to be 50 times 9.81. Is that right? Right? The force of gravity, the actual weight, is 50 times negative 9.81. All right, let's say 50 times 2 is 100. We get negative 100 on the left-hand side. We get negative 490 on the right-hand side. Let's take the 490 over to the other side by adding, because it's a negative number. So we end up getting negative 100 plus 490. 491 is 391, right? So Fn is 391. So I asked you for the normal force. It works out to be 391 newtons. I also could have asked you for, I asked you for the force of the floor. I also could have asked you for the normal force. I also could have asked you for the apparent weight, how heavy the guy feels. And all three of those would have been the same answer, 391 newtons. Is that good? All right, that was the only elevator problem that people need to gone over. Sorry, it wasn't the only elevator question that we needed to go over. We also needed question number 4 gone over. 4 is a really, really straightforward question, though. You want to find the weight of the person in the elevator. I think it was Josh that was asking me about this yesterday. He said, was it you, Josh? He said, basically, is it a trick question, basically, right? Is it a trick question? Kind of, because you don't need to do any of that stuff with the net force and so on. What do we define weight as, Josh? Yeah, it's the force of gravity, right? Yeah, I know what you meant there. It's m times g. So let's just multiply 75 kilograms times 9.81. It gives me 736 newtons. Done. If I ask for the apparent weight as opposed to the actual weight, then it would be a new story. Whole different story, because we'd be solving for the normal force, which would mean we'd have to go through that process that we went through in the last question. Next question was number 6. Looks like we've got all of these pulley problems. All of these pulley problems seem to give us a bit of a problem. Let's take a look at one of them, and let's take a look at one of the more complicated ones, maybe number 8. Okay? I think if you're able to do number 8, you're probably going to be able to do number 6 as well, because in number 8 we've got, it's almost the same thing, except it's a little bit harder because we've got friction involved there. So let's take a look at 8. Try the other ones again yourself. If you have trouble with them, then let me know on Monday, and we'll go over them then, okay? Number 8 says find the force of friction. If we've got a situation like this, 2 pulleys, in between those 2 pulleys is an object with a mass of 3.0 kilograms. We got hanging over the edges 2 masses, one that has a mass of 5.0 kilograms, another one that has a mass of 12 kilograms, and the acceleration is 2.0 meters per second squared. Okay, let's find the force of friction. All right, what I like to do in this, and I've told you this before, straighten it out. Okay, let's not do it this way. We could draw the free body diagram this way. We could say the force of gravity on object number 1 is this way, and the force of gravity on object number 2 is this way. And then the force of friction is going to move to the right because this is a heavier object. The force of friction would act to the left. The only problem that I see when I draw the diagram that way is that I've got forces going in 3 different directions now. Okay, I don't want that. And I don't want 2 dimensions either. I don't want something going this way and then something going this way. And finally, I don't want 2 forces of gravity that are opposing each other drawn in the same direction, because that's going to make me forget to make one of them negative and one of them positive. So what I want to do is straighten it out. What I want to do is change it to look like this. If I've got a 5 kilogram object and a 3 kilogram object and a 12 kilogram object, I've got FG1 acting to the right, okay, and I've got FG2, I should say, acting to the right, and I've got FG1 acting to the left. I also have a force of friction acting on this. It's going to go to the left because the net motion of this is to the right. And we know that because the 12 kilogram object is heavier. All right, let's set it up now. Okay, let's set it up. Let's say F net is equal to the sum of the forces. That's FG1 plus FF plus FG2. We got M times A is equal to the sum of the forces. FG1 plus FF plus FG2. Remember, we're looking for FF. What's the value of the mass that I use when I plug into this expression? Do I use the 5, the 3, or the 12, or some sort of combination of those? Sadie, which mass do I use there? 5, 3, 12, or some kind of combination? Yes. It's going to end up being 20 kilograms. 20 kilograms, it's the total mass. Good. Now, the acceleration is given to me as 2.0 meters per second squared. We can look at this diagram and say it's going to the right in my new free body diagram, so it's going to be a positive 2.0 meters per second squared. FG1, well, it's a force of gravity. It's going to be 5 times 9.81, right? Plus FF plus FG2 is going to be 12 times 9.81. Is that right? Is that right, or am I missing something somewhere? I am missing something somewhere. Bailey, what is it? Good. We want to put a negative sign in here. It doesn't really matter whether you put it in front of the 5 or in front of the 9.81. It gives you the same result. That term has to be negative because in the diagram that I've drawn, I've got it drawn to the left. 20 times 2 is 40. 5 times 8.81 is negative 49.05. 12 times 9.81 is 117.72. Now let's take the 49.05 over by adding. So it becomes 40 plus 49.05. And then let's take the 117 over by subtracting, because it's added to the right-hand side. We get negative 28.67 on the left-hand side. Equals FF. What's the force of friction? Negative 28 negative 28.67, or rounded to the correct number of digits, the force of friction would be negative 29 newtons. Put your head up and get your glasses on. Is that good? Any questions on that? Now, if we look at question 6, how is this different? How is 6 different than question number 8? Well, we don't have the acceleration. We don't have the force of, there is no force of friction. Question number 6, you've got the same diagram, except that there is no FF. It becomes MA is equal to FG1 plus FG2. Okay, you got the values of FG1 and FG2. You get the value of M. Just solve for the acceleration here. Okay, I think that question number 8, of all of those Pulley problems, I think question number 8 is the hardest. If this makes sense to you, I think you should be okay with the rest of them. If it doesn't make sense to you, then you need to raise your hand so we can fix that. We had 10, 11, and 13 for our inclined plane problems as well. I think if you can do 13, then I think you're going to be okay with the rest of them, because 13 is the most challenging of those. Let's take a look at 13 now, see what we can do with that. And then those of you who had a little bit of trouble with 10 and 11, try them again after we do 13 and see what you can do. If you have trouble with it, then see me after class or on Monday. 13, picture looks like this. We get an angle of 30 degrees right here. We get a mass of 10 kilograms. We've got an applied force of 80 newtons. And we're told that the acceleration is 1.5 meters per second squared upward. Not sure where to go with this? We should be sure where to go with this, or at least we should be sure where to start with this. Okay? We may not know how to solve this, but we know how to start it. We always start it the same way. We draw our force of gravity acting down. We draw our normal force acting at 90 degrees. We draw FH, the force of the hill, right here at 90 degrees to the normal force and parallel to the hill. Let's call that FH. Let's label that angle right in here, 30 degrees. Let's get the value of FH. Okay, you're not sure where to go with it? Get the value of FH. Sine 30 degrees is equal to opposite over hypotenuse, and the hypotenuse is 10 times 9.81. Multiply those together, we get 49.05 newtons. Now, yesterday, the day before, we looked at a couple questions where we also had to find the normal force because we were looking for the coefficient of friction. I'll give you a little hint here. If you don't have a problem involving coefficient of friction, you're probably not going to need to find the normal force. We don't need the normal force in this question. Having said that, if you get it, if you get the normal force because you're not sure exactly what to do with the question, that's fine. It's just a little bit of an extra step that you've done that you didn't need to do. That's okay. It's better to do too much than not enough. We've got FH here. Let's straighten this out a little bit, okay? We don't have to, but let's do it here. 49.05 newtons to the left. We've got the applied force to the right, which is 80 newtons. I don't need to bother drawing gravity and the normal force here. How come? I've already got it, right? I've already accounted for gravity and the normal force. Although I don't see them directly in this diagram that I just drew, the force of the hill already has gravity and the normal force. In fact, it is gravity and the normal force combined. Now the next step, always the same at this point, always. The next step is to say F net is equal to FH plus FG, the sum of the forces. Sorry, FA, I should say. FH is, we'll just put the expressions in there again. M is 10 kilograms times A is 1.5 equals negative 49.05. What do we got? Oh, sorry, we're missing something here, guys. What are we missing? What are we missing in this question number 13? I start plugging in numbers and I realize I've got all the numbers. That doesn't make any sense. Hayden? Force of friction, good. Devin, which way does friction act there? Up the hill? Down the hill, yeah, yeah. Why do we say it's going to act down the hill, Devin, do you know? Yes, but there is a force of the hill going down as well. So how do we know which way it actually goes? No? Okay, that's fine, that's fine. Laura? Yeah, the acceleration says it's going up the hill. And you can also look at it as FA is bigger than FH. So that tells us also that it's going to go up the hill. And if it's going up the hill, then friction's going to act down the hill, right? So let's draw friction to the left. Okay, we missed it, but it's not really a big deal. We can just add it in here now. All right, it's all good now. M times A is equal to negative 49 plus positive 80 plus the force of friction. Take this over by adding, take this over by subtracting, and when we do that, we should get a value of the force of friction to be negative 16 newtons. We could have predicted it was going to be a negative number, right? Because, again, it was going up the hill. Friction must be down the hill, which means it's going to be negative 16. All right, guys, let's take a look at question 14 just as an example, okay? 14 has an inclined plane. Once again, we have an angle of 30 degrees. And we have an object that's 5 kilograms on the side of this. We also have a pulley over the edge. And we have a mass of 5 kilograms hanging over that edge. There is no friction, thankfully, in this question. But it's still a tricky question because we've got two questions in one. We've got the pulley and we've got the inclined plane. I know that I didn't assign this for homework, but did anybody actually do this one? Yeah. What'd you get, guys? Same thing? No? Maddie, what'd you get? Okay, the answer is 2.5. So 2.45 rounded. And we'll take a look at why exactly we got that here. Not sure where to go with it? Well, let's draw a diagram. We know we have a force of gravity acting down on this one. We also have a force of gravity acting down on this one, as well as a normal force. The normal force and gravity combined on this one, as they always do, give me the force of the hill. That force of the hill that's perpendicular to the normal force and parallel to the hill. Let's straighten this out now. If we straighten it out, it should look something like this. We got a 5 kilogram object. We got another 5 kilogram object. On the second 5 kilogram object, we have a force of gravity acting to the right. And on the first one, we have a force of the hill acting to the left. Does that make sense? Is that okay, guys? Only two forces. That's a lie. There's not only two forces. There's more than that. But we've combined gravity and the normal force already into one force. So at the end of it, there's only a couple forces if we've combined those gravity and normal force. Let's get the value of FH. Okay, we're going to say sine 30, because we know this is 30 degrees again. Sine 30 degrees is equal to opposite FH over the hypotenuse. That's 5 times 9.81. FH is going to be equal to 5 times 9.81 divided by times sine 30 is 49.05, 24.525. Is that right? There's FH. The value of FG here is easy. It's 5 times 9.81. That's 49.05. All right. Net force is equal to the sum of the forces. What value of m do we use there? The entire mass, good. The acceleration, we're told, we don't know. We're trying to find it. FH is negative 24.525, and FG is positive 49.05. Add these up on the right-hand side, divide by 10, and we should get positive 2.45 or positive 2.5 meters per second squared. Do you see how easy it is in the end to do a question like this that we've never seen before? You know, a pulley and inclined plane problem in one? Okay? We're smart enough to do this. If we can do the pulley problem and we can do the hill problem, then we can do this question. We can do the inclined plane problem. Okay? Now comes the most fun question. Well, it depends on your perspective. For some of you, it'll be the funnest question you've ever seen. For some of you, not so much. Here's the question. Let me explain what's going on here, okay? You've got a 500 kilogram object on an inclined plane with an angle of 30 degrees. That's easy, because we put that 30 degrees in there to make it easy. Sine 30 is equal to 0.5, so the numbers become kind of easy there. And look at that, we got a pulley. We had a pulley in the last problem, and then we've got an object kind of on the other end of that pulley. That's easy, right? Yeah, that's the same as we did in the last question, that last example. This one, we throw a little bit of a wrench into it in that we have two coefficients of friction, a coefficient of static friction and a coefficient of kinetic friction. We're not sure which one we're going to use right now. We've got to see if it moves or not. If it moves, we're going to use kinetic. If it doesn't move, then we're going to use static. It's up to you to find out whether it moves or not, to know which friction you're going to use. Now, it gets better. Oh, it gets way better. Not only do we have a situation like we had in the last question with friction added to it, we have a guy inside that box. And that guy inside that box is going to accelerate with the box. He's going to accelerate either, presumably upwards, since he's sitting on the ground there. As he goes upwards, he's going to throw a ball at 20 meters per second at an angle of 30 degrees. Now, he's going to do that not right away, not when he's on the ground, because that would be too easy. He's going to throw it after he's been moving for 4 seconds. So I guess that tells you what kind of friction we're going to be dealing with, right? If he's moving for 4 seconds when he throws the ball, then we're going to be dealing with kinetic friction probably. Your question is, how far is that ball going to go? Isn't that a good question? If you like this sense of accomplishment by solving a really hard problem, then this is a great question for you. Otherwise, it's just a hard question that you just don't want to see. Nevertheless, it is what it is. I would like everybody, I know that not everybody's going to get this question. In fact, typically when I give this question, there may be 1 or 2 people that get it, maybe. But what I'd like to do is have everybody work on it. Do what you can. Come up with thoughts, okay? I don't care if you get the right answer. I want you to solve as much of this problem as you can. If there's a part of it you can't do, move on to another part. You know that this is going to be several different things. Okay, so do one of the things, even if you can't do the other thing. That's okay. Get as much of it done as you can. Okay, and look, if you can get the right answer, then even better. Yep.
After 4 seconds, does it stop and then he throws it?
No, that's a good question. Does it stop after 4 seconds and then he throws it? No. He throws it as it's moving after 4 seconds, which makes it even harder, right? But that's the fun part. Okay, let's see what you can do.